This update improves resilience for agents and CLI-backed runtimes during four common failure modes, especially important for long-running or network-sensitive workflows. Interrupted tool calls. If a CLI command times out or gets cut off mid-execution, the runtime now aborts cleanly and retries. No more stuck or inconsistent agent states. Stale session bindings. When a session key no longer maps to an active conversation, for example, after gateway restart, the runtime detects it and refreshes the binding instead of crashing. Compaction handoffs. If summarizing a long conversation to manage context fails, OpenClaw retries using the session's configured fallback model chain. Media delivery retries. Failed image or audio uploads now retry gracefully without cascading errors. This is critical for multimodal workflows. This update improves reliability for OpenClaw's real-time mobile and chat delivery across major platforms. Users will notice fewer dropped messages, smoother message sequencing, and more consistent delivery, especially important when using OpenClaw as a personal or team assistant across multiple platforms. The fix addresses underlying connection and message queuing issues that previously caused delays or missed messages during high load or unstable network conditions. Since OpenClaw routes all channel traffic through a single gateway process, this stability boost applies uniformly across all supported platforms without requiring separate configuration per channel. Anyone relying on OpenClaw for time-sensitive notifications, team coordination, or mobile outreach, for example, support agents, creators, developers, will benefit most. The change is transparent, no new setup needed, but makes daily use more dependable. This update tightens control over operations that could previously stall a run indefinitely. Provider and plugin requests now have stricter limits on timers, retries, OAuth lifetimes, media downloads, local service probes, and generated content polling. Why it matters. Without these bounds, a misconfigured provider, slow external service, or stuck retry loop could hang an entire run, especially during onboarding, auth, or content generation. For example, why it matters. Without these bounds, a misconfigured provider, slow external service, or stuck retry loop could hang an entire run, especially during onboarding, auth, or content generation. For example, OAuth refresh or device code flows now have enforced timeouts instead of potentially looping forever. Media downloads and local service health probes also now respect configured limits, preventing stuck waits during model server startup or file fetching. Users who rely on provider plugins, like custom MCP servers or OAuth connected services, will notice fewer hangs during setup or runtime. The retry policy already caps transient error retries and uses exponential backoff. But now those retries are further constrained by overall time limits. Similarly, local service probes, used for on-demand model servers, and polling paths for generated content, for example, scraping or polling APIs, now have explicit timeouts instead of relying on defaults that might be too long. In short, fewer silent hangs, more predictable run behavior. This change reduces redundant work during frequent runtime operations, like skills updates, session metadata changes, gateway state tracking, plugin loading, memory watching, and store writes, without altering how configuration, dispatch, or Linux file watching behave. The key improvement is in how OpenClaw handles hot path mutations. Instead of repeatedly cloning or rereading large data structures, for example, sessions.json, for each small update, the gateway now reuses a validated, mutable cache during active write slots. This avoids expensive operations on critical paths where many small updates occur in quick succession, like when multiple tools write memory or the gateway refreshes plugin metadata. For example, session store writes now flow through a per store writer that serializes mutations without file locks, and hot path helpers borrow the already loaded cache while holding that slot. This means large session files aren't reparsed or duplicated for every metadata tweak. Users benefit from smoother performance during high-frequency activity, like long tool loops, frequent config reloads, or multi-agent coordination, without needing to change any settings. The behavior of config reloading, file watching, and dispatch remains identical, so existing workflows are unaffected. This fix improves reliability when skills or plugins reference secrets, like GitHub tokens, that aren't available in certain contexts, like WhatsApp sessions. Previously, if a skill's secret ref, for example, environment default GitHub pat, couldn't resolve during a channel turn, it would crash the entire agent, even if the skill was disabled. That made WhatsApp unusable for users with such skills configured. Now, OpenClaw more clearly handles stale or disabled snapshots. It avoids evaluating disabled secret refs during channel turns, preventing unnecessary failures. Operators also get clear recovery guidance, like warnings such as configured token unavailable in this command path, instead of silent crashes or misleading success states. Users who've seen WhatsApp agents crash repeatedly with secret ref unresolved errors, even after disabling the skill, will benefit most. The fix ensures disabled skills don't block unrelated channels, and operators can now more easily distinguish between transient resolution issues and misconfigurations. This release expands OpenClaw's orchestration and plugin delivery capabilities across 4 key areas. Workboard now supports orchestration metadata like auto decompose, default assignee, and orchestrator profile that OpenClaw records and exposes to workers. This lets teams define and enforce workflow rules directly in board cards, improving automation consistency. Secret Ref plugin manifests. Plugins can now declare secret ref exec provider presets via plugin integration in their manifests. OpenClaw resolves these at startup using the installed plugin's metadata, ensuring secure, up-to-date secret resolution without hard-coding credentials. Hosted iOS push relay. Official iOS builds now use OpenClaw's managed relay instead of publishing raw APN tokens to the gateway. This improves security and simplifies push registration for distributed iOS nodes. External Copilot and Token Juice packaging. GitHub Copilot and Token Juice are now packaged as installable plugins, broadening OpenClaw's integration surface. Users can enable them via plugins.allow, and OpenClaw handles runtime bridging, chat routing, and tool execution. Each change makes OpenClaw more extensible, secure, and production ready for teams building complex agent workflows. This update makes Skill Workshop's Control UI significantly more useful for teams managing agent skills. Now, when agents draft reusable workflows, operators see a full proposal list, not just raw files, and can review today's pending actions in one place. Revision handoff is clear. Proposals include hashes, support files, and rollback metadata, so changes are traceable and reversible. Searchable file previews let you quickly scan proposal content without opening files and review states, for example, pending, approved, or rejected. File previews let you quickly scan proposal content without opening files and review states such as pending, approved, or rejected, give immediate status visibility. Locale coverage now aligns with OpenClaw's broader internationalization support, so proposals respect language and regional formatting rules. Reusable session routing means a file previews let you quickly scan proposal content without opening files and review states, for example, pending, approved, or rejected. Give immediate status visibility. Reusable session routing means once a proposal is approved, it integrates cleanly into active sessions. No manual reboots or config reloads are needed. This means agent creativity and human oversight. It turns ad hoc skill proposals into a structured, auditable workflow, ideal for compliance, collaboration, or scaling skill development across multiple agents and workspaces. When loading chat history on startup, messages you're in the middle of sending stay visible instead of disappearing, preventing jarring UI flicker. Streaming now delivers content incrementally and skips expensive markdown processing until streaming finishes, reducing perceived latency. Drafts remain local while you type, avoiding premature server round trips. And the composer clears automatically after sending to reduce clutter. First output latency is now traced for debugging, and the initial connection gets priority to get you into the chat faster. Composer controls are also calmer, fewer sudden UI jumps or distractions. These changes make interactions feel snappier and more predictable, especially during startup or when streaming longer responses. Users who rely on real-time chat workflows, like developers testing agents or teams using integrated channels, will notice smoother, more responsive behavior. This release fixes several critical provider and model issues. First, Google Gemini models now use the correct native transport instead of incorrectly routing to OpenAI's responses endpoint with a 401 error. This was happening because the new AQ API key format wasn't triggering the right provider routing logic. Second, Minimax M3 is now fully supported as a chat model in provider onboarding and catalog resolution, with explicit model definitions for Minimax M3, 2.7, and 2.7 high speed. Third, OpenRouter gains SQLite-based model caching, improving performance and reducing redundant API calls by persisting model metadata locally. Fourth, Copilot now supports Claude 1 million token context windows with dynamic catalog refresh from GitHub's/models endpoint to match per account entitlements. Fifth, Microsoft Foundry reasoning alignment ensures consistent thinking level handling across proxy and direct catalogs via shared provider SDK hooks. This change improves reliability during restarts and local monitor recovery by moving key state, like iMessage monitor status, inbound queues, and plugin install records into SQLite. Previously, these relied on file system scanning, which could cause duplicate processing or missed messages after a restart. Now, OpenClaw stores a per account cursor in SQLite for iMessage catch-up, so it resumes exactly where it left off without reprocessing old messages. The inbound dedupe cache still absorbs any overlap, but the SQLite-backed cursor ensures consistent, minimal scanning. Similarly, plugin install metadata now lives in the shared SQLite state database, so restarts don't rescan the file system to rebuild the install ledger. This means faster startups, fewer duplicate operations, and more predictable behavior, especially for users running local monitors or restarting the gateway frequently. This change is transparent. Existing workflows, like iMessage replay through catchup.enabled, continue to behave identically, but now with better resilience and less overhead. This change improves failure diagnostics across OpenClaw's CI, release, Docker, end-to-end, plugin install, and diagnostic lanes by capping excessive logging and data collection, like response bodies, readiness probes, and child workflow waits, so failures report bounded proof instead of stalling. Previously, unbounded logs or payloads could cause test runs to hang or produce overwhelming output, making root cause analysis difficult. Now, each step, for example, Docker image builds, plugin installs, status polling, enforces limits on what gets captured and reported. For example, response bodies and readiness probe outputs are truncated, and child workflow waits no longer accumulate unbounded logs. This means when a CI or release lane fails, engineers get concise and reduces flaky test stalls, especially in automated pipelines where timeouts or log overflow previously masked real issues. Users who run local end-to-end tests, install plugins, or rely on OpenClaw's diagnostic tools, for example, OpenClaw Gateway Stability, will see faster, cleaner output and more reliable failure reports.